All right, guys, we're going to talk about area between curves. Now, we know that the integral of a function, okay, produces a signed area, a value. Signed meaning if it's above the axis, it's positive. If it's below the axis, it's negative. Could be 0 if it cancels out. If you're asked to find an actual area, though, like there's a difference between if I say find the integral of something or find the area. Area needs to be positive, okay? So, to find the area between two curves, it's pretty straightforward, you guys. And I would think that you would probably, like, conceptually, like, just understand this. But basically what we do is we take, okay, the area of the top curve. And if I look at that, area goes all the way down to the axis, right? It would be that area, minus the area of the bottom curve. Okay? So it's like if I took out the top and then I got rid of the bottom, what would be left? Well, the part that would be left would be this area in between. So that's how we find the area in between curves. Okay? We always go from A to B, where A is the lower number, B is the higher number. It's always top curve minus bottom curve. Okay? And left to right on the A to B. All right? Okay. Now, this is in terms of a dx, meaning if I am finding my area as a dx, I'm measuring it that way. There will be certain cases where we will actually want to do our area as a dy, and we will want to measure it that way. Okay? Or in this case, like that way. Depending on which way you measure it. Now, if we do it as a function of y, instead of top minus bottom, we go right minus left. And then from here, instead of left to right, guess what we do? We go bottom to top. All right, and I'll show you guys some examples of that. So let's look at this first question, though. And it would definitely make the most sense, for example, 1, to do this as a dx, okay? Because top minus bottom, so my top curve is y equals x squared plus 2. If you know what these graphs look like, it can be like really helpful. And then my bottom curve, right, is just the line y equals x. Okay, and it wants me to go specifically from 0 to 1. So this is how I would set it up. I would go top minus bottom dx from left to right. And I just go ahead and integrate this. I can't combine anything on the inside, so I'll go ahead and do this. I'll go, okay, the integral of x squared is x to the third over 3 plus 2x. The integral of x is x squared over 2. I'm evaluating that from 1 to 0. So when I do top minus bottom, when I plug that in, I get 1/3 plus 2 minus 1/2. And then 0 plus 0 minus 0. And so I end up getting, oh gosh, let's put these all in. I mean, okay, on a free response, actually, I would just answer it like this, right? If it was multiple choice, let me get a common denominator of 6. So that's 2/6, 12/6, minus 3/6, so 12, 14 minus, so that would be like 11/6, and that would be my area. Okay, so the area of this shaded region right here is 11/6. All right? Okay, now sometimes it won't tell you what the boundaries are. You have to actually figure it out for when you do your integral. And this is when it's really good to know what graphs look like. Okay? All right. You guys, you know that y equals x squared is a parabola. Okay? X equals y squared is a parabola on its side. So my standard x equals y squared is that parabola right there. But then I'm going minus 3, so it's going to move it to negative 3 on this axis. All right? So it's kind of good to know how to graph this stuff. You could also plot some points. Like you could say, okay, if y is 0, x is negative 3, so that's the point negative 3, 0. If y is 1, x is negative 2. And if y is 2, x is 1. But then it can also be the point, like if y is negative 1, x is negative 2. And if y is negative 2, x is 1. So anyway, you can like kind of graph it, or you could just know that that's what x equals y squared looks like. Okay? So there we go. All right. Now this line, this is a line y equals x plus 1. That's a y-intercept of 1, and then I go up 1 over 1, up 1 over 1. I can also go down 1, left 1, down 1, left 1, down 1, left 1. Now, if you graph that very, very carefully, you can see where they cross. We still want to show our work to find out where they cross, but you can kind of see it. Okay? Okay, so I'm going to find the points where these cross. Well, because I'm doing a function of y, whenever you guys see something on its side, I want to do this as a dy problem, not a dx problem. So I would like to find out where these intersect, okay? Now, in order to do a dy problem, you actually need both of these x's, both of these in terms of x, like solve for x. So I have that equation, solve for x, and that equation, solve for x. And you guys, if I set those equal to each other, so if x is y squared minus 3 and x is y minus 1, I should be able to figure out where these cross, okay? Let me subtract this y over. So I get y squared minus y. Let me add this 1 over. Minus 2 is 0. I'm going to factor this to minus 2 plus 1. And I get y is 2 and negative 1. Let's kind of see if that makes sense. So the y-coordinate, does it seem to cross at a y-coordinate of negative 1? And does it seem to cross at a y-coordinate of 2? And it does, okay? And again, because of the dy, I've got to set this up a little bit differently. Instead of top minus bottom, I've got to go right minus left, okay? Now what I'm doing is, so I'm looking at this curve right here, and I want this area. And so I'm going to take the right minus the left. And the right-hand curve is the line minus the left-hand curve is the parabola. So I'll do the line, x equals y minus 1, the parabola, y squared minus 3, as a dy. And then I'm going to use these points. So I've got to go from negative 1 to 2. So I have to go from bottom to top. All right, and then I can just proceed to go ahead and integrate that. But that's how you do this as a dy. So we're going to practice both. All right. Okay. If I like combine this a little bit, y minus 1 minus y squared plus 3, I'm just going to write it in an order that I like a little better. Minus y squared plus y plus 2, evaluated from negative 1 to 2. Okay, so this gives me y to the third over 3 minus y squared over 2, plus y squared over 2 plus 2y. And then it's just crazy like fraction stuff, all right? Okay, when I go to plug in 2, I get negative 8/3 plus 4 over 2, which is 2, plus 4. When I go to do the negative 1, I get negative negative, so I get positive 1/3. A negative 1 squared is plus 1/2 minus 2. Now, rather than getting common denominators at this point, here's how I like to do it. I'll just take this, negative 8/3 plus 6, minus, and I'm going to go ahead and distribute the negative to everything, minus 1/3, minus 1/2, plus 2. Now, I can add the thirds together, and negative 1/3 and negative 8/3 is negative 9/3, which gives me negative 3, and then I can add that together, plus 8 minus 1/2, which gives me 5 minus 1/2, or 4.5, or whatever. Okay, and that's my area under the curve. Now, you guys, if you wanted to check on a calculator, all right, if you wanted to check this, you could go ahead and just like put this in here, and it's like left minus right, top to bottom. Now on my calculator, I can't exactly like make it a dy, but it doesn't matter because y is just a, what we call like a dummy variable, can be whatever. And so if I'm on my calculator here, and I'm going math 9, I mean, I don't have to use y's, I can just use the letter x. If it's really bothering you and you want to use the letter y, you can, and you would just find that under here, alpha y, okay? But it doesn't matter because it's just a variable. So I did this. I could do y minus 1, I'm just going to type in x. So right minus y squared minus 3 as a dy, and I got 4.5, okay? All right, cool. All right, so let's decide here, do I want to do this as a dy or a dx? Well, the way that you can tell is, first of all, if the equations both say y equals, all right, then I definitely want to do this as a dx because I'm measuring top to bottom, okay? Now, step 1, because this specifically says that this is a calculator question, and this is a lot of what comes up on calculator questions is stuff like this, we're going to go ahead and plot this in my calculator. I'm going to go into y equals, and I'm going to put in the first graph, which was x, the first equation, which was x to the third minus x squared. And then I'm going to put in the second equation. Whoops, that does not say x squared. Hold, please. Minus x squared. Okay, and then my second equation, which is negative x squared plus 4.1x. I'm going to go ahead and graph those. All right? And you guys can definitely see the shaded part it's talking about. It's here and here. Well, what I need to do is I need to find the 3 different intersect points. All right? So I'm going to calculate an intersect point. Come over here, and I'm going to do left, right, enter, first, second, enter. And the intersect point, I really only need to know the x's because I'm doing this as a dx. So this point right here is 2.0248, or I can go 5 or whatever. Okay? And you guys see I'm like writing it right there. All right, that was that intersect point. And then I'm going to find this intersect point, which I'm pretty sure is at 0, but let's just take a look. Okay, let's scroll over here and let's go 1, 2, 3. And that intersect point is at 0, 0. And then I'm going to go here. And I'm going to calculate this last intersect point, which is down there somewhere. 1, 2, 3. And that intersect point is at negative 2.025. Okay, when I round it, so that's nice. All right, so now I actually have to do this problem in 2 separate parts though, okay? And the fact that they call it F and G is to help me when I'm writing this on a free response question, guys. You don't actually have to write the full equation. You can go like this. I'm going to do the integral from negative 2.025 to 0. And I'm going to do an integral from 0 to 2.025. And I have to do top minus bottom, so which one's on the top, which one's on the bottom? Well, if you can't tell, go into the graph, come over to this area right here. Oops, this is where you could use like trace. Okay, I'm going to come over here. And this blue one is on the top. That's the x to the third is on the top. So on this part, and then you see it up here, the negative x squared is on the bottom. Okay, so on that part, I can say, well, that's going to be f of x minus g of x. It's f, it's g, which means that over here it switches and it's g of x minus f of x dx. And sometimes on like FRQs, on word problems, you'll have these ridiculously long equations that you don't want to write. That's fine. Call them y1, y2, call them fg, whatever. All right, and now we're going to go ahead and find these integrals, okay, but we're going to totally use our calculator to do it. So I'm going to go out to Now you could do it from here, and you can calculate the integral, and I can go from negative, negative 2.025 to 0, and it'll shade it in, and it'll look really cool. Oh no, I can't do this. Actually, you guys, I'm glad I noticed that, because that won't let me do one minus the other. I can't do it that way. You know, this is just doing that one, and that's not good. So, hey, glad I showed you that. Okay, so now we have to go out to the beginning. You got to go math 9. We're going to go from negative 2.025 to 0. And you guys, for this one, we're doing f minus g. I don't want to retype them, but if you go to variables and y variables and function, I can write y1 minus variables, y variables function, y2. And I don't have to retype it. Okay, so my first area was 4.202. All right, my second area now, I'm going from 0 to positive 2.025. And this time I'm doing g minus f, so you're going to do y2 minus y1. There's one other spot you guys can find those that I want to show to you. It's under one of the secret keys, which is like alpha something. So it's, sometimes I forget, so I just go through them. Alpha y equals is the fraction stuff. Alpha window is absolute value, some of that other stuff's in there. Alpha zoom, it has to do with matrices. You can see it right there, it says matrices. Alpha trace is your y1s. And then alpha graph is nothing, I guess. What's alpha graph? Yeah, alpha graph is nothing. Okay, so it's under alpha, well, let me do it here. Alpha trace, so it's a little bit faster, so you can go like y2 minus, and then you go alpha trace, y1 dx, which is a fast way of typing that in, and I get 4.202. Interesting. That's not always, I mean, they don't look that equal, but I guess they are. And then when I add those together, I'll just get 8.404 for my total area. Okay, that makes sense? Hopefully you guys are all good with that. Area under the curve is a pretty easy topic. Our next topic is a little more tricky.